Good evening, everyone. Today we are doing our webinar on geotechnical engineering, and I would like to invite the Vice President of Institute of Engineers, Sri Lanka, Engineer Mrs. Kamala Gunawardena, to welcome our resource persons and the members. Over to you, madam.
Thank you, Engineer Banduka. You can hear me now?
Yeah. Yes, we
Okay.
can clearly hear you. Yeah.
Okay. Good evening, everyone. It's a great pleasure and honor for me to deliver these opening remarks and extend a warm welcome to all of you at this evening, this webinar, hosted as part of the knowledge sharing session from the Civil Engineering Sectional Committee, organized for today. First and foremost, I would like to extend a special welcome to our esteemed resource persons for today's session, Engineer Dr. Nihal Vitharan and Dr. Ruoshisu, I think I pronounced it properly, who will be leading our Q&A session on the critical and fascinating topic, Advanced Geotechnical Engineering for Critical and Complex Projects. I would also like to extend a warm welcome to all the participants joining us today. Actually, your presence and engagement are what truly make this event a very successful and a meaningful one, because we are taking a good in the sense, good effort to connect all these internationally recognized resource persons. We are excited to have you here and look forward to addressing the burning questions and issues that you faced and having regarding this geotechnical engineering. Your participations add great value to this session. Today's presentation will be highly interactive, focused on a Q&A format. It's a bit different one for us, where Dr. Nihal Vitharan and Dr. Ruoshisu will delve into key areas that are of great relevance to professionals in the field, particularly geotechnical seismic engineering, geotechnical parameter selection, geotechnical modeling, and any other questions related to geotechnical engineering. Before we begin, I would like to provide a brief introduction to our distinguished speakers. It is my great pleasure to introduce Dr. Nihal Vitharan once again. This is the second time I have do this honor of introducing you at this forum like this, having had the privilege when I was the chair of Civil Engineering Sectional Committee 2 years before. Dr. Vitharan is a graduate of the University of Moratuwa with a PhD in structural engineering from the University of Canterbury, New Zealand. He also holds a master's degree in geotechnical engineering from the University of Sydney and an MBA from Deakin University. With over 40 years of consultancy experience in geotechnical engineering, Dr. Vitharan has made significant contributions to both the technical and management aspects of the field. We are also pleased to welcome Dr. Ruoshisu, a senior geotechnical engineer with a PhD in geoseismic engineering from the University of Technology, Sydney. Dr. Su has over 10 years of experience specializing in various aspects of geotechnical engineering and is known for delivering innovative solutions to complex challenges in this field. On behalf of Engineer Mangal Silva, the chairman of the Civil Engineering Sectional Committee, I would like to express our sincere appreciation to both of you for sharing your valuable knowledge with our IESL members today. We are incredibly grateful for your contributions to this session. Once again, a warm welcome to all participants. We hope that this session will provide you with valuable insights and help clarify any questions or challenges you may have in the area of geotechnical engineering. Without further ado, I will now invite Dr. Vitharan and Dr. Ruoshisu to take the stage and begin the session. Over to you, Engineer Banduka, to moderate this session with engaging and insightful discussions.
Okay. Thank you very much, madam. Over to you.
Okay. Okay, thanks, Kamala and Banduka for the generous introduction. Now, when Banduka contacted me about 3 weeks ago for webinar, I said let's try a new way rather than I am coming and telling uh, things on a typical specific subject. We'll make it a Q&A session. So this is a trial. So it may work, it may not work, but let's hope it is going to work. This is a wide subject matter. So we have tried to focus on real questions raised by some of the members, which Banduka sent it to us. So please feel free to ask questions. I think at the end of the presentation. So these presentations are just to keep it going, but after that it is all Q&A. I need to thank Roshi for agreeing to contribute this one. Incidentally, it is now 11 o'clock at night. So Roshi got young children. And Roshi is one of the rising geotechnical stars in Australia, originated from People's Republic of China, not Republic of China, as your Prime Minister made a mistake. Um, he has been working with me for about last 10 years. So Roshi will run the show and I will also participate as needed. Roshi, you can start now.
Yeah, thanks, Neha. So thanks everyone for joining us in such a wonderful night. All right, so I guess today's presentation will generally touch base on 3 different aspects, including parameter selections, then touch base on the numerical modeling for geotechnical engineers with some past experience in particular cine examples, and then off to Dr. Vesterana for a general touch base on the seismic, geotechnical seismic. So normally to start a geotechnical project or any project involving geotechnical engineers, we always thinking where to get our inputs from, how to select our parameters. So I guess the most basic or best practical way is to start with some desktop studies, and we generally using some estimated based soil type or conditions based on some standardized system such as USCS or AASHTO soil classification system to give us a range of for the deformation and the strength parameters. And if we're dealing with rock more often, then most likely we're looking at literature and the past project experience. So these just give us a bound like upper bound and a lower bound, just to bound our parameters. So in that case, we not go off the chart too much. And obviously, with the progress of the project, we were dealing with more site-specific data. So commonly, we are looking at SPT, standard penetration test, which may offer us the density or shear strength. Commonly, we're also looking at the core penetration test, give us the behavior, the type of the soil, friction angle, and the modulus, etc. Obviously, if we're in rock, sometimes we have to do pressure meter test just to offer us some more site-specific modulus instead of some generic literature data or published data from a site 2 kilometers away. So these in situ test is more to provide us a direct measurements of the soil in the particular site that we're dealing with. And obviously, obviously we need to do some collecting some samples from the site, and we're going to conduct lab testing for a more accurate assessment of the modulus, Poisson's ratio, and the shear strength or modulus as well. Commonly, we're dealing with some triaxial test, odometer test, and direct shear test. These tests offers us give us the opportunity to understand better the modulus and the strength of the material itself. In terms of rock, sometimes we have to, the most of the time, we have to do some UCS test on some collect examples for different types of rock as well. The majority of the time we're going to conduct in the field as well as a point load test, just do everything in the field, and we'll collect the samples to do the proper UCS test in the lab, and then we do a correlation to work out the modulus for the design. And in terms of selection of the input parameters really depends on what kind of project we're dealing with and what's the available constituent model we are looking at. Could be as simple as molecular, maybe some advanced geotechnical constituent model like hardening soil or modified chem clay, or even some other advanced user-defined model, tech constituent model which we're gonna touch base later with a proper example. And of course, we need to understand what's the most sensitive parameters. Maybe it's the Young's modulus, a weak layer embedded into strong layers. That's gonna be really sensitive under seismic condition. Then with the progress of the project, we need to have a proper calibration of the parameters with some back analysis of the field performance data, such as power logging or monitoring data. Once the monitoring data come back, we have the chance to recalibrate our model if it's necessary. How we actually deal with variability and uncertainties. So as you all know, our geotechnical project most likely depends for a large area. Most likely it depends on a couple of boreholes or 10 or 20 boreholes, which are 20 meters away from each other. From 1D, we need to build up a 3D ground profile model to assess the condition, to assess the design, and to to set up the final instrumentation and the monitoring plan to control the construction. So in order to eliminate variabilities and to reduce the uncertainties into a acceptable range, I guess the best way is to start with a comprehensive site investigation, just to collect the data of the soil and the rock properties, understand the geological and the hydraulic conditions, and obviously combined with some in situ tests and the laboratory tests as mentioned before, that would be the best way to start the project and to ensure those inputs are reliable and accurate for in numerical modeling, which is nowadays commonly used in geotechnical design quite heavily. And obviously, the most important thing, another important thing at the beginning of the project is to identify the potential challenges and the design considerations. So such as some hazard geotechnical features, whether we have a fault zone running through our site, or even a dike or hydrothermal altered material. Is there any potential landslides risk, or is there any active, or is the area prone to seismic condition? So these are the things to be considered in the beginning of the project. Then during the design, the best thing to do is conduct a series of sensitivities analysis or assessment to identify which one is the most critical conditions, either it's the strength or it's the deformation of the selected parameters, and then we can focus on put all of our efforts into how we actually define or determine the most critical parameters based on the available information that we have. Maybe we need to do more GI during the progress of the design to understand better, or to have a better understanding of the critical parameters. And again, the use of if in the absence of detailed data, probably we need to go a bit more conservative in terms of estimations, and we need to put in more fat. Means we need to use a higher factor of safety to account for those uncertainties to balance out what is not understanding well. And obviously, once we start our construction, we will receive heaps of data back from the construction field. Then it's the time to refine our estimation of the data if we are not quite understanding them very well at the beginning. A bit things on the modeling side. So how to choose the most appropriate concept model? It's actually quite complicated. So it really depends on what kind of things we're doing, whether we're doing excavation or tunneling, or maybe we're doing foundation design or slope stability. Everything has its own unique consideration inside. And of course, we need to consider what's the anticipated material behavior, whether we are more dealing with small movement, means we're most likely in the elastic range, or we anticipate some large deformation during the excavation. Most likely we hit the plastic zone and then we start moving into large strand deformation, or we are actually dealing with time, such as creep or swelling, which is very closely linked with the time that we conduct our construction. So basically we need to have a series of conversation with our construction team to understand the program of the entire construction life, and we need to adjust the design as per the construction progress going. And sometimes we have to deal with rock, which is most likely anisotropic. It just means we have different properties in different directions. So it really depends on what anticipated material behavior we have. Then we can select our constitutive model. There I will be touch on a couple of past project experience later. Another thing is just to balance out the accuracy and the model complexity. Something like more coolant, which is easy to imply and easy to understand, but this does not necessarily mean it's less accurate. On the other hand, we have lots of advanced models such as hardening soil, swelling models. It does capture complex behaviors, but the price to pay is it contains heaps of parameters that needs to be calibrated or verified. And also depends on the data availability. So basically the in situ test or laboratory test or the GI we did initially, they're going to fit into the selection of the constitutive model. Whether we have sufficient data to support or to collaborate the advanced model, it's a question to ask ourselves before we selecting any advanced model or complicated model to be used. And also on the software or tool side, it really depends on which one is available for us, whether it's a simple spring system modeling software that's available, or we have advanced finite element analysis software which is available at the current condition of the project. That's also needs to be considered during the design. And obviously we have for real project, we do have lots of constraints in terms of financial or time. So that needs to be taken into account as well. All right, couple of past examples. So this is actually a project happened in Sydney, in the heart of the CBD. So we are actually perform a excavation, 30-meter deep excavation in sandstone to form a metro station. Right, we have north shaft and the south shaft. What's linked in between is another pedestrian link. so which links both shafts together. And on top of that pedestrian link, we do have a heritage listed building, and on top of the
owned by a bank. Yeah.
Owned by a bank. Yeah. So we don't really want to really touch the building too much. We don't want to make any cracking into the building. Otherwise, you guys won't be seeing us here today. So this is already done. So everything's safe. The tunnel has been formed safely, and the bank is still there doing their routine job. So which is a good outcome. So in this case, it's actually at the beginning of the analysis. Of the design. We assessed whether we would like to use a more cooler model as a simple, straight, nice, and a straightforward model, or we want to go a bit more fancy in terms of joint to the rock model from the available constituent model in Plexus. So we did quite a bit of analysis using numerical software, and we do had a quite heavy research on literature, seeing what's the behavior or what's the general behavior based on all other projects conducted in the similar surrounding as similar ground conditions. So what we found actually, based on selected parameters, our more cooler model can represent the excavation behavior better than the joint to the rock model available in Plexus. And later on, we also did our monitoring, and we can see we are using arrays of prisms, 3D prism, which can record direction of the prism itself in 3 different directions. Movement in 3 different directions. So we're actually looking at about 12 millimeter, or I think it's about 15 millimeter at the top of the wall itself. So which is quite close to our estimation at the beginning of the project using more cooler model. And obviously we need to keep in our mind that the prism is always delayed. So basically it's just saying the movement itself, it should be slightly more than what's showing here. So from that point of view, we are more comfortable with our more cooler model, and we didn't really manipulate or update the model up during the construction too much.
Roshi, sorry,
Yes.
would you mind tell something about the in situ stresses in Sydney sandstone?
In situ stresses in Sydney sandstone. So it's actually quite common if we're dealing with Sydney sandstone. So we're normally looking at the K0. We do have interlocked stress in the sandstone. So the K0 is ranging from I think it's ranging from 2 to 4.5 as a maximum. So basically we have one portion of vertical stress can equivalent to 4.5, as much as 4.5 portion of horizontal stresses in the ground. So what does that mean? That means once we open the ground, there's a immediate deformation going to happen due to the release of the stress, of the in situ stress from the excavation itself. There's quite a bit of published data occurred, and also we combine our understanding of the project and the in situ test to form the best situation or best condition of the in situ stress to be used in our particular project at the particular location. Because dealing with rock, the most critical thing is to understand where the bedding going and where the joints is dipping to. So these are the things, and how close the joints are against each other. These are the things that come impacting on the behavior of the excavated wall. I guess that's the sandstone part. So that's a more cooler. So that's a general condition, excavation condition. So later on, we have to design the pedestrian link with links between north-south shaft and the north shaft underneath the building. So for a localized high-risk area or part of the design, we decide to go a bit more refine the model. So in that case, we select the straight deck, which is a DEM model, so discrete element modeling technique, to proceed or to perform this design. And or also, in order to support all the identified footing underneath the building, the bank on top of the pedestrian link, we also performed even more localized model to understand the behavior of the tunnel liner, permanent liner, and the temporary steel sets underneath the footing from the bank itself. So in order to set up the model, we have to collect all the information around the site from any existing rock mapping during the tunneling around the site. And also we need to constantly update the model during the excavation or proceeding of the tunneling to better perform the behavior or to predict the behavior of the tunnel itself and the design performance, to reassess the design performance. So at the end of the day, we can see here the blue and the yellow line are the prediction based on two different steel sets steel set size, and the dark blue dots are actually the tunnel convergency array recording. This is in terms of vertical deformation from the crown. So to me, the prediction itself is actually quite good. So basically, our recorded monitoring data is still within the predicted range, and also in general, it won't be exactly the same, but in general, it does show the similar pattern of the data itself. Another project that we're dealing with, another won't say problematic, but it does give us a little bit issue, which is in the western portion of Sydney. We are dealing with Benjeli Shell, which is quite famous for its swelling behavior. But before we touch on the swelling, what I would like to share here is we actually assess the behavior of the excavation. Sorry, it's an excavation of 20-meter deep station box, which is about 200-meter long, and I think it's 30-meter wide. So again, we start our project with Molecular model behavior as our constituent model, and during the design, we have been challenged saying, okay, if the geotechnical interpretation report has been given us the hardening soil model parameters, why not we using them then? And our answer is very straightforward, saying because these numbers are basically coming out from the molecular, so they won't be too much different. If we don't have enough lab tests to support or to mimic the behavior of hardening soil model, then it's a waste of time to do those kind of advanced model in the practical project. And we did our demonstration by running a sensitivity analysis using two different constituent model, molecular and hardening soil, and then coming out saying, okay, there's a less than 5% difference in terms of the behavior of the piled wall. So we are very comfortable to carry out our design based on molecular parameters, which is easy to understand and easy to be applied, and quick in terms of computational time. Okay, that's the general behavior of the wall. And unfortunately, we're dealing with around 10-meter soil, and also at the bottom of 10 meter, we're dealing with benjelly shell. And the swelling behavior is another headache item that we need to be considered. So if you can see at the left bottom corner of this of the screen, that's the number of parameters that we need to be considered to perform the swelling at the to consider or to take into account of the swelling effects in the design. So I think it's around 26 different parameters that we need to consider. So with that, if we think back our modular, it's only the modulus, Poisson's ratio, C-5-, basically that's it. But if we need to consider swelling, it's another 26 parameters. And also we need to understand the program of the project as well, because it's time dependent. And there's a little parameter called ANO from Plexus. It's available in Plexus already as a user-defined constitutive model. There's a little parameter called ANO, which is a time controlling parameter, controls when the swelling strength hits 100%. So it's fairly sensitive by the given range. Either we can as early as 20 or 30 days hit the maximum swelling, or we can go more than 100 days, not even hit the 100% swelling. That's another sensitivity thing that we need to understand. And also swelling potential of benjelly shell is really confinement stress dependent. If we do have lots of confinement, like anchor the wall in front of excavation, we are not anticipating too much swelling strength happen, or in other words, we not anticipate too much additional deformation. And if we do not have any confinement in front of the surface, then we are anticipating quite a bit of deformation happened once the shell, once the excavation phase being exposed. So during the design, we actually conducted quite a heavy analysis. So by considering the swelling behavior, we do receive around 2 millimeter lateral movement behind the wall. But at the end, at the bulk excavation level or at the finished surface, we do receive an additional 10 millimeter base heaving that we need to be considered during the construction. So that's just another demonstration of the confinement pressure working on the swelling effects.
And sorry, Roshi,
yeah.
we put a 3-day time limit. So what happened with benjelly shale is when exposed to oxygen or atmosphere, it swells and loses strength as well. So the one of the things we adapted is as soon as you excavate, we put 50 millimeter mortar, and it's stable. And you can see on these right hand bottom, those angle ones, they are ground anchors. What are they? Are 27 strands, and some are about 45 meter long. So they are temporary, but they are the ones keeping the wall safe. And we had very tight deflect controls on the deflections, because another contractor is going to come and build a permanent one in the middle. So that was the challenge. As soon as we introduce water even to the anchor bar, we lose the strength. So we had a very tight quality assurance and control in place. Thanks, Roshi.
Yep. Thanks, Nihal. Some limitations of the software itself. So Plexus, which is generally using, it's quite commonly used nowadays because it's a user-friendly interface. Some limitation, I guess, if we're talking about 3D, it does allow us to do quite a bit complicated 3D geometries. However, with complicated geometry, it also causes issue in terms of meshing. That's quite challenging part to set up the model. And Plexus has its own limitation in terms of dynamic analysis or earthquake analysis. On the other hand, if we're talking about some software from Itasca, FLAC, UDEC, or 3DEC, so they are continuum and discontinuum different basis model. Their interface is not that user-friendly. It's actually code-based. So it's pretty hard for a new user to get their hands on. They do require a very steep learning curve for those codings and advanced features in the models. Once we're talking about 3D model, most likely we are limited by the computation power or the time allowed during the project. So that's another limitation of these heavy numerical models. And the accuracy of the results can be influenced by the quality of the input data. So there's a saying in our engineering field is it's either rubbish in, rubbish out. So we need to make sure our input data is reliable, is accurate enough, or we actually assess the range of, we understand the sensitivity of those data. Otherwise, no matter how fancy the model it is, but the results could be way off from the real behavior. Advanced constituent model, yes, they do available. We can find out from different sources, but collaborating the parameters is another challenge part of the designing, routine design. A little bit things on the validation and the collaboration. So for sure, we need to make sure our program has no error. That's the first thing we need to check and double check the input data, whether they are in the right units or we are putting everything in the right place. And determine the source of uncertainties in the model, including parameters, boundary conditions, and etc., etc. So these are the things that really impacts our results. I won't say quite heavily, but they do heavily impacting the results and impacting the direction of the design. Understand the critical parameters means we need to conduct series of sensitivity analysis to make sure we capture the most important parameters, and then we put our efforts into identify or determine those parameters which can govern the entire design. A good practice just to compare the model that built up against any validated data or past experience or any project that has been done in a similar condition. So we have a ballpark number that we can compare with. So we make sure, okay, our model is actually look reasonable and spit out reasonable results based on the input that we put in. And continuously update our model as the new data coming, either it's a new coming from the GI or either it's new data from the monitoring. If necessary, we need to update the model to reflect the newly found information from the field. That's the best way to validate or to collaborate our model for the later on change of the design. Yeah, I think off to you, Nihal.
Thanks, Roshi. Banduga, I think let's take questions on those two. Well, I'm concerned with the time. And then because I have done the seismic presentation before with the what's called American Society of Civil Engineers Sri Lanka branch. So I can go through my slides very quickly. I think it's better to allow for some questions to be raised.
Yeah, thank you.
Yeah, we do that. Yeah, thanks.
For the participants, if you have got any questions related to what discussed or any other thing, you can ask them now. I think now you can unmute yourselves and can ask questions. Meanwhile, I will raise one question which was in the chat box. That is regarding DCP tests and Macintosh tests. he had asked whether they can be really used. What is your opinion on those results like that?
Roshi, you can answer, then I will answer. I don't know what Macintosh test is.
DCP. Okay.
Yeah. DCP,
Dynamic
okay.
cone penetration. I think somehow it does give you
Yeah.
some data. But
Yeah, let me answer, Roshi.
yeah,
DCP is mainly we use here for pavements, shallow things. The problem with DCP is that there are not many correlations. That's the problem. You know, SPT, probably they did SPT before I had been born. CPT. So that's the problem. DCP mainly used for like rather than doing CBR, we do it for shallow investigations, mainly for pavements, buildings, and that sort of things, not for complex projects. We could only give the near surface data. Sorry, I don't know what Macintosh test is. It's like maybe a deflectometer. Yeah, that's the main with DCP can use, but you can't do it for deep foundations and only for pavements. Because the main thing is correlations are not there, even for drain, non-drain.
Yeah, thank you. And how did you consider the vibration created by the boring machine in tunnel boring?
In which boring?
In tunnel boring.
Yeah, we require, depending on the type of the structure nearby, main thing is, Roshi, we put peak particle velocity. If it is an old tunnel, that should be less than 5 millimeters per second. And tunnel boring machines are fairly nowadays very quiet compared with drill and blasting. And also the advantage that is the ground disturbance, display, the ground movements are very limited because it is basically very smooth operation. On the suburban rail link, Roshi, what do we have for TBM? Only peak particle velocity and the settlement, isn't it?
that's it. Yeah,
Yeah.
and also different ground type will have different types of TBM. Some strong rock will probably just go through it by itself, or well, fairly strong rock. If it's too hard, then TBM can work. And some soil mix with weak rock, then most likely pressure equivalent EPB, a special machine can be used. So basically, we are trying to limiting the impact to the ground settlement. Then to and also for a safe operation. So just to select different types of machine to perform the TBM.
Yeah, some TBMs operating in Australia, some are about 1 billion, Australian dollars. So they're very expensive machines.
Okay. And again, there's a question about these SPTN values. Is there any correlation between consolidation parameters and SPTN value? Or does SPT not having a direct relationship with consolidation?
No, there is no direct relation. Only thing with N, you can get the Young's modulus, but there's no direct. The problem with correlations is so many correlations, and you can get widely varying results. But there is no direct correlations. The primary consolidation, CCE, things like that. There's no direct correlation. You had to do the audiometer testing. I don't think even there's a Roshi correlation between N and the overconsolidation ratio.
No, I'm not aware.
No.
CPT sometimes can give, but SPT definitely not.
It is CPTU. CPTU means CPT with the piso cone. It measures the pore pressure. Yeah.
Yes.
So from that you can pick up OCR. If a material OCR, when it is being sheared, it creates negative pore pressures. When it is normally consolidated, it tends to contracts and it creates positive pore pressure. So CPTU, that piece of cone can pick that up.
Okay, and regarding that tunnel boring machine, that the question asked by engineer Kapil, he just texted that in Singapore there are several TBM stuck in the ground. What caused it like that?
Probably, but we got one stuck here on Snowy too.
Yes,
Is that,
has
what
been
is
stuck
it?
for more than a year.
What is what is the name? Florence. Yeah, that's partly poor. Less. See, let's get back to more. Less geotechnical investigation one does, more uncertainty in the design and the construction. So if you want to reduce construction risk, you have to do more GI. There are clients who think ground investigation is a waste of time. And also they offload that risk to a contractor. Contractors are coming to make money. They're not doing charity service. That's the difference. Yeah, probably government, bureaucracy, corruption, they do. But contractors want to make money and go home. They're not doing charity. So as soon as less GI, contractor take their risk, sometimes they get stuck. So tunnel boring machine getting stuck is poor GI. What happened? Some rock, it's called, I think, Hawk and Brown got a paper called Good Tunnels in Bad Rock. Some rock tends to squeeze, especially sedimentary rocks in North America, South America. They squeeze. Once you excavate and leave it for some time, it squeezes. So you can't move the TBM either way, front or the back, until you deassemble it and bring piece by piece to the surface. It is happening on a project in Sydney called Pump Hydro Snowy too.
Yeah, just have a bit further elaborate on the snowy thing. So initially they hitting the super hard rock and the TBM stuck there, and they spend quite a bit of millions on the horizontal boreholes to understand what's ahead of the TBM, and somehow they managed to go through the hard zone. Now they start again because the ground now changing to some softer material, more fractured rock, and the TBM is not really suited for those kind of condition, and they got stuck again. So it has been years they're not even moving too much for further
Yeah.
for the Snowy Hydro 2.0.
Yeah, I was involved in that project during tender design, and I pointed out, and we pointed out, there are not enough boreholes to understand the geological
alignment.
uncertainty. Yeah, in the alignment. Roshi knows I was involved in the tender design, so that's what happened. As I said, design and construction projects, contractor is coming to make money. And if you have the designer working for contractors, Roshi and I have been working for contractors on DIY. Contractor doesn't want you to do conservative designs because that's their money. They have put a price, so they have to get it done, delivered under that price. So DNC is, it's difficult. You can't make it too conservative. Contractor goes bankrupt. You can't make it less conservative. Project is going to belly up or, get stuck. Yeah.
Okay, thank you. And there's a bit long question. I will read it.
It's not longer than our presentation, is it?
No. If there is a thick clay layer around 50 to 60 in thickness, what are the solutions to reduce the settlements? In Southeast Asia, when doing pavement design, contractors use concrete base to avoid the settlement issues. But with the time, the concrete base also cracks due to the settlements in their due to the settlements. Is there a solution to avoid the high settlements? Uh, that is the question. Engineer Anushka, can you? It's good if you can speak and explain it a bit.
Is it one of the projects you guys constructed from Colombo to Kurunegala, is it?
No, it's a project in Southeast Asia. He's working there.
Okay.
Uh,
Yeah, the
let's
settlement,
see.
uh, are you okay? See, let
He
me
will.
answer without knowing. It's a
Yeah.
pavement, heavy trucks or taking push bikes, different things. Sometimes those clay settlement could be the reactive clay. Because otherwise, I can't see 50-meter thick that deep affected by vehicles on the road. So there is no easy solution. If it is a rigid pavement, concrete pavement, somebody should not have adapted rigid pavements, do a more flexible pavement. And because you can easily, it doesn't crack, it will just settle and have bumpy road. Otherwise, it's put in like PVC drains to get rid of the water, or preloading before constructing the road. So if settlement causing cracking, probably need to have a flexible pavement. We are not pavement designers.
Okay.
Can provide some subsoil drain also. Subsoil pipe. We install a subsoil pipe
Okay,
and
PVC
remove
drains.
the.
Yeah.
It's
So
a
that
vertical
will only
drain sometimes.
that would only do is accelerate your settlement. So
Engineer Anushka is available, I think. You can ask it now. Hello, Engineer Anushka. Yeah, we can hear you.
yeah.
The rehabilitation projects. All the projects are like rehabilitation and they are already settled. So although they apply another load, with time it also already consolidates. So their solution is normally, although there's a clay layer around 50 to 6 meters in thickness, they have filled around 5 to 6 meters of the top clay layer with sand. When they construct the roads, they remove some of these sands and put around a CBR 80 ABC layer and then put a concrete base. But with time, although these are rehabilitation projects, this concrete base cracks. There are no solutions to these kind of things because they have already have experienced some load due to the heavy traffic.
Yeah. So it's basically what you have done is a preloading, but again, if the
Preloading, sir. These are
preloading,
rehabilitation projects.
yeah.
So,
So that's what I was trying to say. When people, I think probably Sri Lanka universities too, they don't spend much time teaching engineers what is OCR, imports over consolidation ratio is. Because if a material has already consolidated, when you put a load less than that preloading or pre-consolidation pressure, displacement is very negligible. As soon as you exceed it, it's going to behave like a normally consolidated clay with higher deformation. So what you have done is preloading, but I think it's an issue in some places like Thailand, change in tide levels and all that cyclic loading. But sometimes the solution is not to have a rigid pavement, have a more flexible type pavement. Concrete, yeah.
So we have the both types. We have the rigid pavements and the flexible pavement both, but
Yeah.
both have the same issue. That's the thing, sir.
Yeah, same issue, but it is easy to repair a flexible pavement, isn't it? Than a concrete.
Yeah, the thing is when they rehabilitate, what they do is they remove the asphalt layer and do another asphalt layer on top of that road. Just repair some concrete layers and do because it's easy. But
I think so. Putting, as I said, PVC vertical drains, it's only accelerated the consolidation process. So ultimately, whether you have the drains or not, total settlement is the same. So that's what it's important to manage the construction sequence with your sub drains. So if you put preloading and then put the vertical sub drains, it will consolidate a lot more settlement. Then you come and put the road, less settlement.
Okay, okay, sir. Thank you.
Okay.
Yeah.
Thank you, engineer. And what is opinion to model PT soil characteristic in soil models?
Pete.
Yes, Pete.
Yeah, Roshi, man, I have worked in Japan long time ago. The problem is peat is a very difficult material to model. So as I said, like we do swelling modeling, you have to really do lab testing, specialized lab testing to understand the behavior, because its permeability change a lot with the compression, or and also its characteristics change too. Peat is, it's organic material. So answer is, unless um, test data is available, any modeling you do is a waste of time. Probably if you drink beer, buy beer and drink it, you get 5 or 10 cents back by recycling. That's a good excuse to drink beer.
Okay. And the next, there are several more questions.
I think let's go through those questions. Seismic
Okay.
may not be that important, but I'll cover that in 10 minutes.
Okay. What are the advantages of discrete element method over finite element method?
Roshi?
Well, yeah. It really depends on the available information that we have. If we do have enough mapping to support us to build in the defects or joints or beddings or footing faults correctly, or in the right location, the best the discrete elements has their obvious advantage, because we can model the rock and the joints separately, and we understand where's the losing part. If we're dealing with tunnel, we understand whether we need a potential crown support, or if there's any potential rock falling, a rock wedge formed at the crown that we need additional bolts inside. However, if we do not have accurate information or sufficient information to support us to build in the discrete joints or faults, then I will go through the final element by itself, because in that way we actually, at least we're blending the behavior of the joints into the material or into the rock mass properties. So in general, we can capture the behavior of either tunnel or tunneling or excavation in a big picture. But if we're really dealing with detailed, let's say maybe 10 meter cube area or something slightly larger than that, I will try my best to understand the ground, and try my best to dig out the discrete defects network or phase mapping to build up the discrete elements, especially for sensitivity and impact assessment. That's the best way we can see at the moment, because that captures quite a bit of other behavior that cannot be captured in the finite element method.
See, thanks, Roshi. Basically, if your discrete joints are very close, high density, they turn into a continuum model anyway, because when you use continuous, we are using rock mass properties. So rock mass has two things: intact rock, that piece of rock you take it to your hand, and also the joints. So when we do the rock mass, joints and the intact rock are lumped together. So normally what we use Hawke-Brown criteria, we take intact rock, unconfined compressive strength and Young's modulus, and then do the joint mapping. And then we do a thing called GSI, Geotechnical Strength Index, or Q, that's coming from Norway, and then get the equivalent rock mass properties. The discrete one is important. Normally what we find, Roshi and I do a lot of work, in strong rocks, you may have persistent isolated joints. In that case, that joint behavior is very important. In that case, discontinue model like 3-day or what's the other one? RS2, is that right,
UTech,
Roshi?
RS2 as well. Yeah.
Yeah, they are important. But otherwise, doing discrete modeling when you got very closely space joints is again a waste of time, and you won't get any accuracy. Whatever it is, when you do a tunnel, you need to have a geologist pointing out where some rock pieces need to come out or they need to be bolted. So that's the answer.
Okay, thank you. And the other question is about piling and its impact to surrounding properties. The question is there was a construction very closer to the current property, and the distance to the nearest pile is around 3 meters. So any cracks can be developed in that other properties after a long time of that piling activity, or just only during the piling. That is the question. Maybe some experience.
I think if it is happening, it should happen immediately. Unless the pile is carrying some lateral loads or vertical loads. If it is coming later, don't blame the contractor who constructed it. You need to blame the designer, because if you got 3 meter another building and you build this new pile foundation with a tall building, the loads acting on the pile will disturb the ground, or what we call these interaction factors. So here, I think Roshi, piles have an interaction at a distance less than 5 to 8 times the diameter. So what's the diameter of your pile? Do you know the diameter of the pile?
Engineer Hiranti, if you are available, you can explain it more.
So 3 meter, 3 divided
Hello?
by 8. Yeah.
Yeah.
I actually don't know the diameter of the pile. No idea. I'm actually the neighbor who is objecting to this site, but I'm worried about the cracks formed in my house.
Has it been built already, or?
Its piling is almost over.
Yeah. Then
Construction.
if it is not loaded, it's something to do with the piling vibration. So they need to select we don't do displacement piles, basically hammering a pile that close. No, we always board
They are
piles.
doing electrical piling or something.
They
So
try to
will
keep
it
that must be electrical piling must be to keep you happy, but electrical
the damage is the same, no?
damage is the same. So
So my question is now, once the building comes up 16 stories with that load, what will happen to the adjoining properties?
probably you need to buy another building, move away. See, as I said, if it is 3 meter away, 3 divided by 8, how much? 400 millimeters. Is it? Yeah. So So if they are putting a 600 millimeter diameter pile, 600 times 8 is 4.8. Anything less than within that distance will get disturbed. And 16 story high will carry heavy wind load. So that's putting lateral loads into the pile. Lateral loads are the ones causing more damage near the surface. Sorry?
Yeah, you can continue. I'm just listening because
somebody, whoever approved it, needs to be the engineer. You need to go and see him tomorrow.
Can I actually contact you like later?
No, I don't want to get involved in litigations. Yeah, so I think who is the designer? Where is it, in Colombo or where?
Yeah, it's in Colombo 13.
Colombo 13. That's Fort, is it? Oh,
yeah, near Fort area, Fort, the harbor area.
So you can mention the guy said, whoever the engineer who is designing that need to be more careful. Sometimes.
Yeah, he told he can't take the responsibility. I actually called him. He said he can't take the responsibility. He has given the instruction how to do. So that is my worry.
Now, when you build something 16-meter high next to 3 meters, sometimes we tend to hear sleeve the pile. So that means the pile got 2
Yeah.
to 3 meters gap with the steel, so it doesn't put loads at the surface. So 16 stories. 16 is about
50-meter height.
50-meter high. It's quite tall. Yeah.
Okay.
There must be some authority approving it, isn't it? Government authority in Sri Lanka.
Yeah. UDA, Urban Development Authority. Actually, I have complained to the Institution of Engineers also.
Yeah, so here you go. Probably you have carrying some what's the placards in front of the Institution of Engineers.
Okay.
Kamala
Yes,
madam is here. Okay, yeah. You
Yeah,
can
next
discuss.
question.
I have been listening and I thought of getting this issue discussed in another forum because there are a lot of technical issues and maybe others have some technical questions as well. Yeah, Ms. Hiranti, I think I will look into that. I didn't know actually there was a question like that. I mean, issue
Madam
like that.
Kamala, Madam Kamala, can I come?
Yes,
I'm
sir, you
Mangal
are there.
Silat. I'm Chairman Civil Engineering Sectional Committee. I think the answer is very clear. Of course, we can understand the problem. Am I audible? Am I audible?
Yes,
Yes,
yes.
you can. We can hear you.
Actually, this issue should goes to the UDA because they are the approving authority, and
Exactly.
whoever the structural engineer doing the design, he is responsible, right? So basically, all these calculations and the investigation reports, everything should be with the UDA. So definitely you have to complain to UDA, not the Institute of Engineers Sri Lanka, because
I have
Institute
made a
of Engineers Sri
complaint
Lanka
to
is for
UDA.
something else. So
Yeah,
you
made a
have to
complaint
complain
to
to
UDA.
UDA because IESL doesn't have any authority to stop the building. So therefore you have to go to UDA. So I think that's the answer. Thank you very much.
So what happened
Okay.
in this quite a little bit interesting. If the engineer who has designed it is incompetent or unethical, where do they complain? Is ICL has anything to do with it?
It's like this. If he has done some, if definitely he cannot be incompetent because he should be an structural engineer with a charter, and specifically
Okay.
he should be qualified enough to design this much of storage, because in Sri Lanka we have a separate Institute of Engineers Sri Lanka published a separate directory. That means one set of engineers can design up to 4 stories basically. And after that, 8, 12, 20, about 20, like that, right? So we have checked their capabilities and we have updated, we have created those things, right? So definitely UDA will stick to these things and they will check. So that's how they are checking the capability, right? Number one. Number two, if they have done something unethical, yes, IESL can handle that part. That is for the disciplinary action or something. But I mean, if there is something in between, then definitely the insurance companies has to tackle this one, right? Or the client. That's how the things are happening, because that's the thing is in Sri Lanka. We definitely this type of building is going to do. We have a habit of putting insurance, right? Definitely. Then we have whatever the damages comes to the other adjacent buildings. Answer is very simple. Either they have to go to the courts and get the damages, or else normally this type of cases are not going to courts. So if the client is willing to support and do the required rectification, so this is the situation. Okay.
Okay. Thanks.
I think
Anyway.
actually Mangal,
thank
I
you.
think I can add little bit for that, because if there is incident something like that have occurrences, because normally we do a crack survey and the preliminary survey and the after things, so there are documented things. So if this is happened due to this construction, I think that is obvious. And at the same time, I think as you said, designers are responsible for designing this thing, and also it is approved by the client. So there are correlation between these organizations. So we have to look into that way.
Yeah. Okay.
Okay. Thank you, madam. And the next question was to Dr. Rushi. You have presented 2 case studies of excavation, and how was the dewatering carried out there?
Oh, so 2 cases of studies that presented in the presentation. So the first one is mainly in the Sydney sandstone. So we don't see too much dewatering required, because the majority of the time it's gonna be it's a drained excavation. So they have allowed for seep through the excavation surface. On the other hand, on the other side, at the other one, so half 10 meters in soil, 10 meters in the Benjali shell. Yeah, we do have vertical drains behind the pile of the wall to control the water and to collect the water at the base of the excavation and transform them into the nearby sump.
So basically on the second one, between the piles, the
Mm.
gap we put strip drains and then put shotcrete, and those
Yeah.
strip drains take the water down and discharge or pump it out. But in those projects, in addition to the geotechnical interpretation report, there should be a hydrogeology interpretation report. So those reports are mandatory.
Okay, thank you. And I will ask one more questions, then we can move to these other things. Yeah. One more. Explain the correct method to determine the actual level of rock layers when boring using a winch boring machine.
Proceed with the piles.
I don't have experience with the winch boring machine though.
Okay.
What's a winch machine?
It's
like auger, is it?
Yeah.
I don't know, to be honest.
So there are, I guess there are 2 ways. One is you need to have a experienced geologist present. Sometimes looking at the color and matching with the boreholes, they can determine, like Sydney sandstone to up to 3 and 4, they can easily pick up the difference. And then some projects we put a 360-degree teleweaver. It's a camera that can pick up on serious projects. Yeah. Otherwise, some countries they can lower a guy and into the borehole, but it's not allowed now in Australia.
Is a winch boring machine another way to say augering?
I think so. Yeah.
Okay, then we can actually tell the material from the color and the comeback chips, and whether they have fresh weathered or it's freshly smashed from the rock, or it's have already weathered in the ground. Then we can roughly tell whether it's what kind of class or weathering has been experienced, and we can somehow compare with the nearby borehole to understand where we are away approximately. Okay. But to be honest, there's no accurate enough way to identify the level of rock itself. I mean, if you're talking about half meter, most likely you can, because the majority of the time you can pick up the chips and then look at the angle of the chips. If they're quite fresh, like a fairly sharp, then most likely it's from fresh rock. If they are rounded, then most likely it's from weathered rock. And if we're talking about a millimeter level accuracy, then I don't think this augering machine can return those information to us.
Yeah, again, thanks, Roger. Again, it comes to SSGI. Now, the monopile, large diameter monopile on big supporting big bridges, so even tall storied buildings like the Martin Place, we do a borehole prior to at each pile. So you know exactly the strata you will be encountering. And here the bridge, our code or the Transport New South Wales say there should be a borehole within 10 meters of a pile for a bridge.
Okay, thank you. And I think, Dr. Nihal, now we can go for this geotechnical seismic part.
Yeah, Roshi, you can
Yep.
operate the. So
Yeah,
what I thought is a widely varying and difficult subject, and I did a seminar. I think November 2021, organized by Sri Lankan, American Society of Sri Lankan branch. Even I got a seismologist, well-known seismologist, Dr. Tim Mott. Now, it must be on their website, but I was told the recordings done somewhere in India and he's not returning the recording. So you need to talk to Dr. Laksiri. It's quite comprehensive. So what I did here is, I knew we may struggle with the time. I just put questions and some generic introduction onto the seismic engineering and touch on some of things like liquefaction. Yeah, Roshi, next one. So this is in Sri Lanka. I think there is a sort of myth or saying that we are immune against earthquakes. Always people tend to challenge it, but because it's an island nation, normally when you said island, like Christmas Island off Perth, has very high seismicity. So there is, when Dr. Tim Mott presented that webinar with me, he pointed out they are somewhere in the system or in Sri Lankan records, and the most credible one is by I think Professor Seneviratne from University of Peradeniya. So it is, I would say, rather sad to say that engineering community, we don't have earthquakes. But if you look at PGA data, as I said here, they're very equivalent to what we got in Australia. Now, Australia, almost by law, we have to design some structures for 10,000 year return period, whereas in Sri Lanka, still we are designing for 10-year 10% exceedance in 50 years. That's the return period is about 475 years. So this is what I just put for the awareness of the audience that Sri Lanka will have earthquakes. And next one, please. Now I say when it comes to seismic engineering or picking up data, it's not like going and buying a cough syrup. Cough syrup is cure for every cough. This is, I put 2010 Christchurch earthquake. These are within CBD or outer ring of the CBD, how the seismic accelerations change. So you can see no point picking up somebody else's seismicity data and do complex analysis when it comes to Sri Lankan earthquakes. So even this is, you can see it when the earthquake in Christchurch 2010 happened somewhere near the beach. As it came to the city, it had a very different behavior. Near the beach, high frequency, it damaged all the shorter buildings. But when it came to CBD, I lived in CBD, Christchurch, for 5 years. CBD took all the tall buildings off the foundation and put it onto the ground. I think one of the television towers, there's a school and a hotel. I think it killed 126 people. So Christchurch is not densely populated. So to that many people to get killed, you can see the devastation. Currently, they say the Christchurch 2010 earthquake only had a 1,200 year return period. Yeah, next one, please. So that's what I said. You can see the Christchurch. The bottom one is near the beach. When it came to Christchurch, because of the liquefiable alluvium, somewhere 800 meter deep, thick, they had a long period for each vibration. So that means most of the tall buildings went into resonance, because to go into resonance, the natural period of vibration of the building need to match with the dominant period of frequency of the earthquakes. Yeah, next one. Now I just thought vertical accelerations. People say going back 20 years ago, even New Zealand, Australia, or other countries like Chile, they never took vertical acceleration into account, saying it won't be there, only things moving laterally. But vertical acceleration either assumes 0 or 20 to 30% of the horizontal. But if the fault is close to the where you measure it, vertical acceleration can be higher than the horizontal. So that means if vertical acceleration greater than 1g, you will be up in the mid-air. So Christchurch, some places vertical acceleration is equal to the horizontal acceleration. So vertical acceleration basically comes as a compression or direct waves, whereas shear is going to sideways or yo-yo. So two different ways of transmitting it, and they cause different type of disasters. Now, when it comes to liquefaction, as I put the last one, vertical acceleration has no effect at all because it's effective stress doesn't change with the Poisson ratio at 0.5. You can just work through elasticity. If Poisson ratio is 0.5, when you put a load, it's going to hydrostatic pressure. So there's no volume change. Next one, please. Now, one of the question is SSI in seismic events. That SSI stands for soil structure interaction. It can be rock soil interaction. Now, it can be from very simple pseudostatic or pseudodynamic to very complex nonlinear inelastic time history. It's called THSS. That's the most complex. But again, to do that, you need to have good parameters. There's no point unless you got specialized testing done or data from previous trying to do a time history analysis. Just because you got access to a software. So that's so sometimes pseudodynamic people have done a lot of analysis and gave, this is the height of the structure, your acceleration coefficient is 0.5 or 0.3. So that's one way. Basically, it's a simple way of doing or implicit way of doing SSI. Now, one other thing I said is some jurisdictions legally bind the complexity of the analysis. I have done a lot of seismic work in Philippines and Sapporo, Japan. In Philippines, the time history analysis is a must for complex projects like LNG plants, highway bridges, dams. That means when it is legally binding, you can't go away from it. You had to do that, but other places like even Australia, standard is not legally binding unless the state or the federal government say this standard has, we empower this standard to be a law. Otherwise, it's a voluntary organization. What happened? Roshi?
I think the slideshow was.
It crashed.
Sorry, some technical glitch on my side.
It's okay if you can get it.
Yeah, just let me share again.
Can you share the slides?
Yeah, Are you okay, Roshi?
I think got disconnected or something. There was one question regarding that.
Yeah, that's please. Yeah.
Christchurch incident, I guess. So
Yeah.
could that happen because of soft soil amplification, or is that a natural phenomenon?
Earthquake is a natural phenomenon. It's a between the faults or between the plates or within the plates, interplates or interplate. But the how it got modified, like large amplitude, um, uh, less amplitude, long period waves, is because of the soft soil or alluvium in the CBD, close to CBD, and then it of course it caused liquefaction because it loose sand. Like I think probably hydraulically deposit sand is a very bad against liquefaction or prone to liquefaction, like the reclaimed land, like the probably the port city in Colombo, or places like part of Hong Kong. Not working?
No, I think Dr. Rushi, he got disconnected.
Maybe.
Can't see in the participant list as well.
So any other questions meantime?
Uh,
So in Sri Lanka, what's the most popular geotechnical software? Finite element.
Flaxis, we have been
Okay.
using. Yeah. And there was a
Uh,
question from Engineer Ranjan.
Yeah, go for it.
I think now we answered that one. Yeah.
So like, I think the finite element limitations, some of the projects here, the client insists that we should run 2 independent finite element models. So it could be Plaxis and FLAC, or Plaxis and Volop, and Plaxis and UDEC, Plaxis and 3DEC, SWEG, RS2. So that's because of the uncertainty, some of the software when it comes to material modeling, how some materials can behave.
Mhm.
So with earthquake, I think another one is liquefaction. So liquefaction is basically effective, as they were in the slides, but we'll see. Effective is become zero, and it is quite unique with loose sands, mainly hydraulically deposited, that or wind blown, and it won't happen if the earthquake moment magnitude less than 5, and typically that layer is 15 meter, more than 50 meter deep, and also it has a PI greater than 15, opacity index greater than 15%. So that's what they call Chinese or Japanese rule. That seems to be working pretty well. I think another one is if it is liquefiable, what can you do? There are various methods. One is to design your pile foundation, knowing that it will liquefy. So liquefaction has 2 things. One is cyclic mobility. That means when the earthquake comes, it moves left, right. But when earthquake ceased, it will be resting at its original place. Other one is called lateral spreading. That's like a big landslide. And after the earthquake ceased, probably what you can see is a big landslide. So the second one, you can't basically design against it because everything will end up on it's typically happen if you got a creek or something nearby, it end up on the creek or sea. But the first one, cyclic mobility, what we tend to do is we determine the seismically induced deformations, and then we apply it to the pile foundations, like something like L pile. as a deformation-induced loading. Roshi and I have been recently doing a similar for a big project here. The material is going to liquefy. So, and the other one was how to mitigate. Yeah. So that is no mitigation you design against it. Mitigation can be sometimes expensive or counterproductive. If you do any mitigation, like most practical and economical one here is stone columns. That means we hammer stones in the form of columns, like 1 to 2 meter spacing. That does two things: densifies material, or three things: densify the soil as it's displaced. The seismically induced pore pressure. Seismic is when the material is loose, when it settles, it generates pore pressure, they dissipate. Third one is the composite rock and soil. Shear strength is higher than that of the liquefiable material. But I think Russians, Americans, sometimes they drill holes and put the blast, or that breaks the matrix of the sand, and it settles and densify the liquefiable layer. Preloading, dynamic compaction, they don't improve much. They don't improve the resistance against liquefaction much. So it needs to have a good understanding of what you are going to do. And the last thing is to go and put pile foundation, because they attract a lot of loads when the ground is moving.
Okay, I think Dr. Roshi just joined. He can.
Yep.
I think I went through the slides.
I guess that's
with
the
the
last
guy.
thing that Nihal just mentioned on the
Okay.
design. Sorry
Yeah.
for that. I got a bit issue with my laptop. It just all of a sudden restarted.
Do you have that monkey
okay.
you sent me yesterday, Roshi, in your suburb?
No, I probably got squirrel instead of a monkey.
Okay.
Any questions?
I think we have answered all the questions. Yeah.
Okay, we are in
And
time.
okay, yeah. And on behalf of the Institution of Engineers Sri Lanka and the Civil Engineers Sectional Committee, I want to thank everyone who helped to make today's webinar on advanced geotechnical engineering for critical and complex projects a great success. And first, a big thank you to our speakers, Engineer Dr. Nihal Vitarana and Engineer Dr. Roshi Su, for sharing their knowledge and experience. And your talks were very helpful and gave us practical solutions to important challenges in geotechnical engineering. And we really appreciate your time and effort. I know it's, I think, just past at midnight in Sydney, I
12:30,
guess.
yeah, 12:30, yeah.
Yeah. Thank you very much for your commitment and presence today. I really appreciate that. And also, I want to thank the chairman, Civil Engineer Sectional Committee, Engineer Mangala Silva, for continuing this webinar series on technical topics. Thank you very much for the guidance and leadership on that. And also, thank you, the Vice President of Engineers, Institute of Engineers Sri Lanka, Engineer Kamala Gunawardena, Madam, and we had several sessions with Dr. Nihal during her period as a chair of Civil Engineering Sectional Committee as well. Thank you, Madam, for today's presence and guidance.
You're welcome.
And also, I would like to thank all the council members and other past presidents and everyone who attended today. And also, we got many positive feedbacks. I got several messages as well for this webinar. It was very impressive, and there was a request to share the presentations and recording. Actually, we are in our IESL YouTube channel, IESL Media. We will be uploading these recordings. And also, I would like to thank the IESL Secretariat, the IT department for their hosting arrangement. Thank you very much for that. Also, for all the participants today and for your engagement in Q&A session. Thank you very much for that. And also again, thanks to Dr. Rushi. Thanks to Dr. Rushi and Dr. Nihal for your commitment and time for this. And do you have to add anything, Kamala Madam or Engineer Mangalsil?
Sorry, Bandhuka.
No, just Madam, I want to add something. Okay.
Yeah, actually, hold on. Yeah, I think Dr. Nihal, this is not the first time, so this is what I mentioned in the introduction as well, the welcome speech. So, and it's so great that Dr. Roshi, so your presentation as well, and this is very actually high standard. I would say that it's in a very what do you call? It's in a very high standard. I don't get any other word now. And very scientific and very theoretical, mainly theoretical, but you have connected it with the practical situations. I think our participants would have taken a lot out of that. I think that's why they are asking for the presentation. And I think we really appreciate this and happy to have this webinar or the questioning session in a different manner actually. I think everybody were very much relaxed. They gathered a lot of things out of this. Thank you so much for both of, I think. You
Yeah, no,
both did
thanks.
a great thing, great
Thanks,
presentation.
Vanuka.
Yeah.
Vanuka, Kamal, and Mangal for initiating this one. When Vanuka rang me, that's what I said. Let's give it a Q&A session rather than we offload whatever we know. I think
Yeah.
let's see what
Yeah.
feedback you get from the audience.
Yeah, actually, I also really I was really excited and I was thinking why we were not contacting you before. We were waiting for about 2 years. That's what I was thinking when Bandhu we reminded you and we wanted to have a session with you. So anyway, now we have started it again and so you will be getting some more botherings from us. Be patient and we respond nicely. Thank you. Thank you so
Okay,
much.
thanks.
And,
Yeah.
and for the
Roshi, thank
participants,
you. Thanks a lot.
Thank you very much. Thank you
Yeah.
for having us.
Okay, see ya.
Okay.
Take care.
Okay.
For us, it's night. So
Yeah. And for the participants, I just shared our WhatsApp group link. So you can join and keep in touch with us. We will share our next webinars on there and we will share some resources as well. Yeah.
Okay.
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 okay,
Thank
shall
you.
we
Thank
check
you
whether
very much.
Engineer Mangal is around? I don't know whether
I
he can see
think,
us.
he was
hear us.
there. He's there.
Madam,
Engineer Mangal.
actually,
Yeah,
still I am on my way. I think I may not very audible because I'm in a southern highway, right? Okay. I think that first, I would say thank you very much, all. Thank you very much, Bandhu and Kamala Madam, for organizing everything. And thank you very much, our two resource persons. Thank you very much for everything. Thanks. Good night.
Thank you.
Okay.
Thank you.
Good
night,
night. Thank you
everyone.
very much.
Bye.
Thank you.
Bye. Thanks, everyone.
Bye.
Bye.
Thanks, the audience. I think there are about 50 more. Yeah.
Earlier it was more than 100, I guess. Yeah.
Okay.